Okay, so we're back today uh, doing more stuff with vectors. Um, Today what we're going to be finding is what's called the dot product. Okay, to find the dot product is very, very simple. The formula is right here. It depends on the order at which, this, B dot W, right? So that's where I took these numbers. A lot of this won't change because you do have um, the commutative property of multiplication holds true, right? So A1 times A2 is the same thing as A2 times A1, right? The same thing with B. Um, and so, it really doesn't matter which way you multiply. It does because it tells you, but your answer will be the same. And you'll see that in some of our problems below. Okay, so you basically, to do the dot product, you just take the coefficients in front of your i's and multiply them together, and then you take the coefficients in front of your j's and multiply those together, and then you add those products, right? So you're going to get, your answer will be just a single number, okay? So our problems today will look very similar. Um, so it'll give you two different vectors, and then you just have to find the dot product of each of those, right? So v dot w, right? So I'm going to take my 5 times negative 3. So 5 times negative 3 plus, and then negative 2 times 4. Negative 2 times 4. And then I'll just multiply this. That's negative 15. And this is negative 8, so plus a negative 8, right? So if I add those, you get negative 23. Okay. W dot V, right? So now, if you follow the formula, right, you take negative 3 times 5, right, plus, and then you take 4 times negative 2. So then you get negative 15 plus a negative 8, so negative 23. So you can see, like I said before, the property of multiplication holds true. Right? So B dot W is the same thing as W dot B, right? It's a little unlike yesterday, right, where the order, especially when you're subtracting, is specific, and you get different answers. On this, you should get the same thing. Okay, now this is B dot B, right? So you just take 5 times its same value in the I, so right, so it's 5 plus negative 2 times negative 2. Right, now 5 times 5 is 25, and 2 times 2 is 4, so 25 plus 4 is 29. Okay, now the second set of problems will again give you this time 3 different vectors. Okay, now the problems will get a little bit more involved, meaning there's more steps, right? So it's kind of combining what we did yesterday with the dot product today. Okay, so and you solve these just like with order of operations. It still holds true, right? So in this problem, it's u dot the sum of v plus w, right? So you got to follow order of operations. So you got to do v plus w first, then you can multiply. Then you can find the dot product of u and the sum of v plus w, right? So if I do v plus w, I get number. So when you're adding vectors, you just add the numbers, the coefficients in front of each of the letters that are the same. So 3 plus 1. So 3 plus 1 is 4i. And then 1 plus 1j, so it's just j, so it's 1j. 1 plus 4 is 4 plus 5, so it's plus 5j. Right, so that's v plus w. Right, now I'm going to multiply u dot and then this sum right here. Right, so I'm going to take u dot v plus w equals, right, so it's going to be 2 times 4 plus negative 1 times 5. Right, so 2 times 4 is 8, and then negative 1 times 5 is negative 5. So then 8 plus negative 5 is 3. So there you go. Okay, now for u dot v, right? So remember, like yesterday, scalar multiplication of vectors, right? So when you have a number times a vector, so like for u, I'm just gonna take 4 times both the 2i minus j, right? So for u equals, well, that's 4 times 2i minus 4 times 1, that's just a 1j, right? Because I threw in the minus in front of it. So that's 8i minus 4j, right? So it's just 4 times bigger. So now the dot product of 4u dot v equals, right? So now my v is, or 4u, so it's 8. So I take my first value in front of I times 3, right? So that's 3 plus, and then negative 4, that comes from here, and then times 1. Times 1, sorry. So 8 times 3 is 24, and negative 4 times 1 is minus 4, so then you get 1, right? So there you go. Okay, if you have any questions, please leave a comment or email me. But yeah, finding the dot product is very, very simple. So there you go.